Today our lesson is going to be on rewriting quadratics so that we can put it in vertex form. So we're going to start off by reviewing from first semester, completing the square. So to complete the square, we're going to isolate the constant term. So what we're going to do is add 2 to both sides. Once we do that, we're going to make sure that our leading coefficient, which is the coefficient of our squared term, we need that to be 1. So we're going to divide through by 2, and we're going to divide everything by 2. We get 1 is equal to x squared minus 2x. Now what we're going to do, we are going to begin to complete the square. We're going to come up with a value of c that's going to allow us to complete the square. Remember when we took half of our b term? So half of negative 2 is negative 1. And then we squared negative 1. That was the next step in our rule over here. We squared negative 1, and negative 1 times negative 1 gave me a positive 1. To keep the equation balanced, we added that value to both sides. And now this x squared minus 2x plus 1 is actually the same as x minus 1 quantity squared. So you can see where we're going with this to get it into vertex form. But let's keep going. We add our terms together over here, and we get 2. Solving for x, we're going to take the square root of each side, and we get plus or minus the square root of 2 is equal to x minus 1. And we're going to add 1 to each side, and we get 1 plus or minus the square root of 2. Those are our 2 solutions. Now, our next one, we have a y in place, so what we're going to do is we're going to treat it the same. We're going to isolate the constant term. And this time, in order to get a 1 in front of our y squared value, instead of dividing, we're going to multiply by negative 4. We multiply every term by negative 4. So our new equation is negative 24 is equal to y squared plus 8y. Now we're going to complete the square. There is a value that goes here that will allow us to complete the square. We take half of our linear term. Half of 8 is 4, and 4 squared will give me 16. Add 16 to both sides, and when I simplify, I get negative 8. Take the square root of each side, and anytime you take the square root of a negative, you get I. We're not done because we don't have y by itself, so we're going to subtract 4 on each side, and this is what we get. This is a review of complete the square, which is going to lead us into our lesson, rewriting quadratics in vertex form. All right, so here we go. We're going to move the constant term to the other side. That is the term without a variable. So we put it on the other side with y, and now we have y plus 2. We're going to divide all terms by the leading coefficient so that we can make this a 1. So we're going to divide through by 2. When we do that, we have y over 2 plus 1 equals x squared minus 2x. Now, we need a value that's going to allow us to complete the square. So we need a value here. I'll call it a value of c, because this is my a, this is my b, and this is my c. I need a value of c that will allow me to complete the square. So I'm going to take half of my b term, which is x minus 1 now. And when I square 1, I get a 1, and I have to make a 1, add a 1 to the other side to keep my equation balanced. Understand that this complete the square when it is factored is actually this right here. So now we have our y over 2 plus 2, because 1 plus 1 was 2, is equal to x minus 1, this quantity squared. Pause for a second and let's think, what are we doing? We're trying to write the quadratic in vertex form. So next we are going to subtract 2 on each side. And when we subtract 2 on each side, we have y over 2 is equal to this expression minus 2. Now what's the last step so that we can get y by itself? We're going to multiply everything by 2. And when we multiply everything by 2, here is our quadratic. It is in vertex form, and it is y is equal to 2 times the quantity, x minus 1 squared minus 4. Let's talk about the vertex. Now that we have it in vertex form, what's the vertex? Okay, so this is our h and this is our k. The opposite of your h. So it's 1 comma negative 4. That's the vertex. We actually found the intercepts in the warm-up. So that's 1 plus or minus the square root of 2. And because it is an x-intercept, we need an x value, so the y value is 0. Now what's the y-intercept? Well, the y-intercept is when you let x equal 0 because we're trying to get a value for y. And when we simplify this, we get y is equal to negative 2. There you go. So if we were to get a calculator and graph this on the calculator, we would see this y-intercept as 0, comma, negative 2. However, we need to try to practice doing these by hand without a calculator because you could see similar questions on the SAT as well as on your final unit test. You'll have a part where you'll have to graph without a calculator. Rewriting quadratics in vertex form. Well, wait a minute, this is x. So what do we know about this quadratic? Well, it's turned on its side. All right. However, we're going to go through the same process. We're going to go ahead and isolate the constant term. So we are going to put it on the other side. We're going to move it to the other side. So it's not really isolated because it's over here with x. So I can stop saying that. And now that we have that, we have a negative in front of y squared. So we have to go through and divide everything through by negative. Now we have our leading coefficient is now 1. It's time to complete the square. We need a value here, a value of c that will complete the square. We take half of our linear term, which is negative 6y. And half of negative 6 is negative 3. So we begin to complete the square. 3 squared is 9, so we add a 9 to both sides. And the only like terms over here, 9 and 1. When I simplify that, I get negative x plus 10 is equal to the quantity y minus 3 squared. Trying to get x by itself, I'm going to subtract 10 on each side. And when I subtract 10 on each side, this is what I have. Can I stop right here? Absolutely not. What is my very last step? I need to go through and either multiply or divide everything through by negative 1. You got it. When I do that, I get x is equal to negative the quantity y minus 3 squared plus 10. That is the graph. Next question on that problem. What is the vertex? But this begins with x, so we got to be careful here. So we do a switch, 10 in the front, 3 in the back. What's in parentheses? The sign changes. X-intercept. We let every y equal 0, and we solve for x. And x is equal to 1. We write it 1, comma 0. Y-intercept. We let x equal 0. We subtract 10, we divide by negative 1, we take the square root of each side, we get plus or minus the square root of 10 is equal to y minus 3, and we add the 3 to both sides. There we go. Alrighty, rewriting quadratics in vertex form. When we have a leading coefficient, that's a fraction. Notice how we continue to go through the same steps. We are going to move that constant term to the other side. So we're going to take this negative 6, we're going to add 6 to both sides, and we get x plus 6 is equal to negative 1/4 y squared minus 2y. I need my leading coefficient here to be 1. So I'm going to multiply everything through by negative 4. Here, here, and here. And my new equation is negative 4x minus 24 equals y squared plus 8y. So now do I have a leading coefficient of 1? Yes, so I could begin the process of completing the square. Alrighty, so I'm going to take half of my linear term, which is 4. So this is y plus 4, 4 squared, 16. Add 16 to both sides. The only like terms are these two. So I add those together and I get a -8. I'm going to add 8 to both sides and I get -4. X is equal to this quantity squared plus 8. I need x by itself. Remember, this is our quadratic that is turned on its side. So I'm going to divide everything through by -4. And look what I get. X is equal to -1/4 times the expression y plus 4 squared minus. Let's talk about what's the vertex. These are key points right here. So how do we put them in the vertex? -2, -4. Find the x-intercepts. We let y equal 0 and we simplify. X is equal to 6 and y would be 0. Y-intercept. We're going to let our x equal 0. We could take a look at problem B, but if we have an I in our problem, what are your thoughts on that? Thank you. Share it with your teacher.